All right, so finish up with section 7.5. So 7.5 is on compound interest. So basically, interest is money that is paid for being allowed to use that money. Okay? For example, in a mortgage, the bank is allowing you to use their money, so you're going to pay them a fee for that. Okay? And likewise, if you put your money in a savings account and you allow the bank to use your money, they're going to pay you for that. Not as much, but they are going to pay you a little bit. The total amount of money that you invest or that you borrow, that's called the principal. So if I'm buying a $200,000 house and I take out a $150,000 mortgage because I put $50,000 down, the $150,000 mortgage, that's the principal of my loan. That's the amount of money that I have to pay back the bank. And then on top of that, they're going to add interest. Okay, well, there's different ways we can calculate interest. So what we're going to do is we're going to start off with the simple interest formula. Okay, now I'm going to tell you right up front, this is not the formula that a bank would use. Okay? But it's a good way to just start and look at the basic idea, and then I'll show you the one that they really do use. Okay, so the formula is I equals PRT. Okay, interest equals principal times rate times time. So principal is the amount of money that's, in our case, we're going to look at it as like a savings account. It's the amount of money that somebody put in the savings account. R is going to be the rate. Okay? The rate, that's the interest that they're going to make. It's important that you write your interest rate as a decimal. So for example, 5%. If you were making 5%, it'd be 0.05. Okay, and T is the time in years. Okay, so let's look at this one. So this one says that you're going to borrow $2,000 at a rate of 6% for 2 years. How much interest do we pay? That percent that we're seeing right there, that 6%, that's actually, in terms of mortgage rates right now, that's pretty accurate. Okay, we just looked at mortgage rates a little while ago. We saw they were between 5 and 6%. It's pretty good. But if you walked into the bank and you said, look, I'd just like to borrow $2,000 for a personal loan. We saw that was quite a bit higher. Let's just take a look at it. Was it 11?
It was like 11.25.
So if you just want to take a personal loan from the bank, you're going to pay for it. You're going to pay a lot. Car loans, mortgages, those are a little lower. Okay, but that's a reasonable problem. Right, so the first thing we need is our formula. Interest equals principal times rate times time. Okay. Which one of those numbers is our principal here? Yeah.
Oh, 2,000.
The 2,000. Okay, the principal is the amount that you're borrowing or investing. Depends on which way we're looking at it. Okay. What's our rate? What's the rate of interest I have to pay here? Is that
6%.
6%? And how would I write that as a decimal?
0.06.
0.06. Okay, now we're taking this loan for 2 years. Okay, that's my time. T is always our time in years. Okay, so let's see how much we would end up paying back in interest. If we borrowed $2,000 at 6% for 2 years, assuming simple interest. This is a simpler formula. So it's 2,000 times 0.06 times 2. Okay, so it doesn't seem like too much money. $240. So you're going to pay back the bank the $2,000 plus $240 in interest. Okay, any question on that? Okay, so that's basic simple interest. Okay, next I want to take a look at compound interest. Okay, and compound interest is the way that the banks actually do interest. Okay, so compound interest actually is better for you. Okay, if you're putting your money in a savings account, you make a little bit more with compound interest than you would with simple interest. Okay, so compound interest is interest that the bank would pay you, or you'd pay the bank if it's a mortgage, but interest that the bank pays you. But it's interest not only on the amount of money you put in your savings account, but you also earn interest on the interest they paid you. Interest, yeah, it is, interest.
You ever say words you make title that just sounds funny?
That's one of those words, huh?
Like what?
So, for example, let's say, just to make it simple, let's say in January, you put $100 in the bank account. At the end of the month, maybe 1%, you made $1. Well, now in February, you're going to make interest again. But you're not only going to make interest on the $100 you had in there, you're also going to make interest on the $1 they gave you in January. Okay? So maybe at the end of the month, instead of making $1, you make $1.05 now. All right? So each month, you start to make more and more interest because it starts to build up. All right? So that's compound interest. It's interest you earn on your principal and on interest that the bank previously paid you. Okay, so let's try to do this one. Okay, we've got a rate of 8%. We're making a $1,000 deposit on January 1st. I want to know how much money I'm going to have after a year. Now, the one thing we got to take into account when we deal with compound interest is how often do they compound it? Okay. Quarterly basically means you're going to earn interest January, all of February, all of March. On the last day of March, the bank will take all that interest and put it in your account, not before that. So even though in February you might have made a little interest, the bank's not going to give it to you. They're only going to give it to you 4 times a year. Okay? So quarterly, just let's start with January through March. Let's see how much interest we would make just through that time period. Okay? January, February, March. That's a quarter, the first quarter of the year. Well, we're going to use the same formula we did before. Our principal is $1,000. Okay, my rate is 8%. But Iris, can you tell me what that rate would be as a decimal? It's 0.08. Okay, and now I need my time. Okay, be careful. What's my time here? It's not 3 months. Well, overall it's going to be a year, but what's January to March? How much of a year is that? January, February, March. It's a quarter of a year. It's 3 out of 12 months. So my time is 1/4 of a year. So let's see how much interest we make from January to March. $1,000 times 0.08 times a quarter. Okay, we make $20. In January, just January to March. Okay, so now on March 31st, what's going to happen? The bank's going to take that $20, they're going to deposit it into your account. So what's going to be your balance on April 1st? Now you have $1,020. That's your new principal. What would the next? April, May, June. Yeah. So now the interest you earn from April to June, it's not only on the $1,000 you put in January, but it also includes the $20 the bank just paid you in interest. Everything else stays the same. Still making 8%. April, May, June. It's another quarter of a year. So how do you think my interest is going to compare in April to June? You think I'm going to make more interest than I did in January to March, or less? A little bit more, because my principal is a little bit higher. Let's see what we make. Make 1,020 times 0.08 times 0.25. Not that much more, but a little bit. $20.40. Usually with money, we don't write it as 0.4, you write 0.40. Okay, so now at the end of June, the bank's going to take $20.40 and deposit that into your account. So what's going to be your balance on July 1st? Yeah, it's going to be $1,040.40. So we got July, August, September. Okay, so now the interest you earn in these months, it includes the $1,000 deposit you made back January, $20 interest that you made in the first quarter of the year, and the $20.40 interest that you just made in the second quarter of the year. That's my new principal. Now this is assuming you never take money out of the account. You just let it sit there. Okay. So let's see how much money we make in the third quarter of the year. Should be a little bit higher. We can see, though, it doesn't go up much. It goes up a little. So 1,040.4. Oops. Times our rate of 0.08. Times a quarter. Okay, so this month, now this is another thing that gets interesting in banking, the rounding. Okay, we're going to round this the way we normally would. Okay, $20.81. But what happens to that, that other little bit? Okay, well, there's actually some interesting stories if you read online. There are people that tried to take those little bits of money from accounts, and you'd never notice it on paper. Or it'd be harder to notice on paper because it's rounded. Right? So they took these little bits of money that were rounded off or rounded down, took them for themselves, and people could make tens or hundreds of thousands of dollars taking these little fractions of pennies that hopefully they thought nobody would ever notice. Of course, eventually somebody did notice these fractions of pennies were being taken. But it's harder to notice that on paper. Okay? So let's just round that to 2081. So that's how much interest we made in July to September. At the end of September, that amount of money is going to be deposited into our account, and that's going to give us our principal for the last quarter of the year. Okay, October to December. Okay, so my previous balance is $1,040.40, and we're going to add what we just had. 2081. So now we have $1,061.21. That's my new principal. Bless you. Okay, my rate stays the same. If the rate was fluctuating, that complicates it a little bit. Then you have to deal with different interest rates every quarter. It's not hard, but you just need a different number. We'll keep it simple, keep it the same. Okay, let's see what we make for interest here. So 1,061.21 times 0.08 times a quarter. So this month we make $21.22. So lastly, to answer the question, what's our balance after 1 year? I'll deposit that money into the account, and then we can see what we got. 1,061.21 plus 21.22. So after a year, we'll make $1,082.43. Balance after 1 year.
$82 for a good year's work.
Yep, $82. That's what the bank basically pays you for you giving them your money. Okay. How do you think that would compare to simple interest? Do you think you made more money with compound interest, or do you think you made less money? Yeah, you make a little bit more. Okay. Let's figure out what we would have made on simple interest. Basically, just take 1,000 times 0.08 times 1. The principal times the rate times the time. Let's see what we would have gotten. $80. Yeah, so compounding, we only really got an extra $2.43, but we also only invested $1,000. Okay? So imagine you had 10,000 or 10 million or 100 million. Okay? If you're starting to deal with these amounts of money, these little differences can become much bigger. Okay? So that was compounding quarterly. Okay? Meaning you earn interest, and every 3 months the bank makes the deposit. Now what if I wanted to do compounding daily? Every single day you earn interest, and at the end of the day, 5 o'clock, whatever it is, they deposit the money into your account every day. What would be a pain about trying to do that this way? It'd take forever. You'd have to do it 365 times. Okay? Because they'd be compounding it every day. So there's got to be a better way, right? So instead of calculating compound interest manually, which is the way we just did it, doing it 4 separate times, you could actually use this formula. Most of the letters are the same. Okay, this formula is going to give us a total amount. So not only will it calculate the interest for us, but it's automatically going to add the interest into the amount. Okay, so A is your amount, P is your principal, R is your rate, again as a decimal. N is the number of times that you're compounding it. So like in our last problem, quarterly means 4. All right, so there's a few terms for the test you should know. If I say compounding quarterly, that means 4 times. If I say compounding daily, assume a normal year, 365, not a leap year, 366, okay, 365. If I said compounding monthly, that's 12 times. If I said compounding semi-annually, semi means twice a year, 2 times. And T is still your time in years. Okay, so let's do the same example we just did. Let's go do example 2 again. This time we can do it all in one step, just by using this formula. Okay, and we should get the exact same answer. Everybody have the compound interest formula? That N and T, those are exponents. And this is where the logs would start to come in. If I asked you to solve for time, okay, if I said, I'm going to give you $1,000 to invest at 3% compounded daily, tell me how long it'll take before that $300 turns into $600, before it doubles. Well, you'd be solving for T. That's a variable in the exponent. That's a log. That's how you'd solve it. Okay, I don't know if we're going to get that far, but. So here's the same problem again. 8% rate, compounded quarterly. What does that mean? How many times is quarterly? 4. So N is 4. Principal's 1,000. Time is 1 year. amount of money is your principal times 1 plus your rate. We already remember from the last problem, 8% is 0.08 divided by n, which is the number of times we're compounding, raised to the n times t. In this case, t is 1, so it doesn't really matter. So now, if everything works out nicely, when we type all that in, we should get $1,082.43 all in one step. Okay, so we get, I'll start inside the parentheses. So 0.08 divided by 4 plus 1. Now I'm going to raise that to the 4th power. Just follow PEMDAS. And multiply that by 1,000. Get $1,082.43.
Now, if the year was anything different, would we multiply that or add it to the 4th? Yeah.
If what was different?
If it was 2 years, for example.
2 years, then this would be a 2, and you'd be raising it to the 8th power.
Okay, that's what I thought.
Yep. That's the only thing that would change. But hopefully you can see how much easier this formula is to use. Okay? Especially if I said I want you to compound it daily. Maybe I want you to compound it twice a day. Okay? So you'll earn interest in the morning, and then at noon they deposit the money, and then you earn interest from noon to 5, and then they deposit the money again. You could do that. Eventually, the more you compound it, the more money you make. Okay? But it doesn't, at a certain point, it doesn't make sense. Like compounding it twice a day, I don't really think that's going to give you much more of an advantage than compounding daily. Okay? In fact, I think your book, they go through an example, and they show you what happens if you invest this money and only compound it once a year, twice a year, every month, every day. Okay? And basically, the difference is about $5 for the amount of money they invested. It's not that much. But it is a little bit. Okay, in our case, I think it was $2.43. Any question on that formula? All right, so if you see a compounding problem, don't do it out manually. Just use that formula. Oh, let's kind of extend that idea of compounding it. Okay, I want to compound it. I don't want to just compound it daily. I don't want to compound it twice a day. I don't even want to compound it every minute. I don't even want to do it every second. I want to do it faster. I want to earn interest, and I want the millisecond I earn that interest, I want it deposited. So I want this compounded as fast as possible. That's called continuous compounding. Okay, what that means is the very, tenth of a second, as fast as you earn the interest, the money is deposited right in your account. Okay, that's called continuous compounding. Let's look at that formula. You know what? Instead of looking at just t, let's make it simple. Look at it when t is 1 year. Okay, just let t be 1 year. So if you're going to compound faster and faster and faster, what letter is that? Is that the A, the R, or the N? That's the N. Okay? So what's happening to N? As you compound faster and faster, N is what? It's getting bigger and bigger and bigger. Okay? Let's look at an example we just did. Just use R as 8%. Okay, and I want to kind of see what happens to that as I let N get bigger and bigger and bigger. Okay? And yeah, this fraction is going to get smaller and smaller. Okay? You're going to take the rate and you're going to divide it by something bigger and bigger and bigger. It's never going to go to 0 though. Even if you only had $1 and you divide it between 1 million people, it's small, but it's not 0. Okay? So you're going to take something that's very, very small, you're going to add it to 1. But then you're going to raise it to a huge exponent. Remember, n's getting huge. Okay, let's just try an example on here and see what happens. Let's let n be, let's try 100. Okay, so let's take 0.08, divide by 100, plus 1, raised to the 100th power. Okay. Get that number. Now let's try it for something even bigger. Let's try 1,000. Let's take our rate divided by 1,000, okay, plus 1. I'm going to raise that to the 1,000th power. Okay, we get 1.08. Okay, well, it turns out if you let n get high enough, okay, eventually the number that this thing starts to get close to is 2.71828. Anybody remember what that number is? E. It actually gets very close to E. And that's where our formula for continuous compounding comes from. And it actually looks a little simpler than the other one. Okay, so if you want to actually try it on your own and see how it approaches E, I think the example the book suggests to use is let R equal 1. Okay? If you let R equal 1, divide it by something huge, like 1,000, okay? Then add 1 to it, and then raise it to the 1,000th power, this should start to look like it's getting close to E. Kind of. 2.71. Change 1,000 to 1,000,000, and that number will get even closer to that number. Okay, so that's the connection a little bit between the compounding continuously and E. All right, so let's try. Did we do $2,000 last time?
Yeah.
Let's see. So on this one we did. That was 1,000. That one was 1,000. Well, let's try 2,000. Okay, let's take $2,000, and we're going to compound it at a rate of 10% continuously. Now, it turns out that continuous compounding, it doesn't really give you that much more of an advantage than daily compounding. It really doesn't, even for large amounts of money. It's not, I mean, maybe if you had trillions and quadrillions of dollars, it would, but for most practical purposes, daily compounding, that's what a bank would do. At most. Probably not daily or continuous. Right, so let's see if we can get this. That's the way I remember it. It's PERT. A equals PERT. P-E-R-T. P-E to the R-T. Okay, Amy, what's my principal here? Yep, 2,000. Okay, E, that's the button on your calculator, 2.718. Okay, my rate, Adam, what's my rate here as a decimal? 0.1. And how long are we investing this money for? Yep, just 1 year. Okay, so let's see how much interest would make if it's compounded continuously. Okay, that's basically the best compounding you could possibly have. It's 2,000 times E. You know what, let me do it in 2 steps in case you can't do it all at once. Just take E, raised to the 0.1 times 1. So you get 1.105. And then my next step is going to be multiply that by 2,000. So you get $2,210.34.
Is there going to be a question like this on the test with E?
I'll probably give you one that has a couple continuous compounding and then one like the other one.
Because I don't have an E button.
I don't either.
An E? Okay, I'll take a look at it and we'll find it. It's got to be a way, there's a way to do it, we'll figure it out. If you have to, you could use the number 2.718 in place of E. Okay? Okay, so that's, let's see, how much interest did we make? 2,000, we made $10.34. Okay? And that's the best possible compounding you could have. That's as fast as you can do it.
So over the year, you can get $10.
Yeah, the interest rate, yep, you're only going to make $10.34. Yep. So now look at that, that's the interest rate here. Imagine the interest rates we just saw on the other page. The interest rates weren't even 1%. What was a savings account? It was, was it even 0.5 or was it like 0.1? So those are checkings, that's different. Savings account. So this savings account, they pay you different amounts of interest depending on how much money you have. If you have between $50 and $500, they'll pay you 0.05%. That's not 1%, that's not even a tenth of a percent, that's half of a tenth of a percent. So basically nothing. The best interest rate they pay is if you have $5,000, they'll pay you 0.15%. Not even 1%.
Oh, thank you.
That's, this is typical for most banks. You're not going to find banks with much better rates, but this one is GFA in Gardner. Yeah. Let's just see quick with simple interest. If you put $5,000 in a bank account and made that much interest, how much would you have after a year? It would just do simple interest to do it quick. So your principal times your rate, well, that's point. So if you had something like 15%, that would be 0.15. So this is 0.0015. So if you take $5,000, invest it in the bank account at 0.15%, you'll basically make $7.50. Okay, not that much. $7.50 after a year. It's 1 year. So you want to know how much you make a day? You make about 2 cents a day, roughly. All right, so not the best interest rates there, but that's probably pretty typical of most banks. Okay. Any question on that? All right, so that's basically how you can calculate interest on a savings account. Either compounded a certain number of times or compounded continuously. So make sure you know that formula for the test and that one.
Yeah, I didn't get the same thing when you did the math on
Which one? This one?
Yeah, I got two.
PE? I probably made a mistake.
Yeah, it's two.
Yeah.
I wrote it wrong. It was just on the calculator.
I wrote it wrong. So E raised to the 0.1. I had the right answer, I just copied it wrong.
Yeah.
Times 2,000. $2,210. Oh, okay.
that. That's what I got.
So that's supposed to be a 2.
That makes more sense.
Yeah, I thought the $10 was a little low for that, but yeah, so you make $210. Thank you. 34 cents. Everybody get that? Okay. Again, if you don't have an E button, you could use 2.718. If you want to be really accurate, use that. But we're only rounding to the nearest penny, so that's more than accurate for what we need in most cases.
Those should be
All right, so the homework for tonight, it's on 498. It's just some quick interest problems. So just 3 through 9 odd.